So far, we talked about motion in horizontal direction, and in this section, we will talk about how gravity influences vertical motion, including free fall, velocity, distance, and acceleration due to gravity. Earth exerts a gravitational force on all objects, pulling them towards the surface of the earth. Sorry, pulling toward its surface near the Earth's surface. This force creates a constant downward acceleration, meaning if we have any objects, whether it's in the surface of the Earth or something's falling from the sky, Earth always has some attractive force moving these objects toward the surface of Earth, and that force is uh, that attractive force creates a constant downward acceleration, and which is called acceleration due to gravity. And this is denoted with the letter g, and the unit of acceleration is acceleration due to gravity is same as just the acceleration. Galileo was the first to accurately uh, measure this acceleration due to gravity. uh, he used a rolling object down an inclined plane to slow motion enough to observe that gravity's effect is uniform over time. So if you have a plane surface and some object is moving along this plane surface, and if you record the position of this object over time, and then you can create a plot where this is position and time, and if you know the position versus time, then the slope will give you velocity, and the velocity of a the slope of velocity versus time plot will give you acceleration. And so based on this information, uh, he he determined that the effect of gravity on the acceleration of the object is constant and it's uniform over time. And so basically, down the line, he slowed the motion enough to establish that the gravitational acceleration is uniform over time, and the acceleration due to gravity is same on regardless of the size of the object. So the acceleration for this object or this object will be the same regardless of their size. And for a vertical motion under gravity, we will set a coordinate system such that our positive y will be pointing down and negative y will be pointing up. Since all the objects will be attracted toward the Earth's surface, it will be convenient if we take the downward or the falling object as a positive direction instead of going upward, because we have to do some work against the gravity in order to throw something up. In this section where we will talk about gravity, we will consider our downward as positive y and upward as negative y. It will make our calculations much easier if we just consider y positive in downward direction, y negative in upward direction. And one more thing is that we will ignore all other factors like air resistance, and we will only be considering the gravity. uh, towards the Earth's surface, and this acceleration due to gravity is a constant number, which is uh, 9.8 meter per second square. But for this course, in order to make it easier for a calculation, we will round up this number and use our acceleration due to gravity as 10 meter per second. And as we talked about it before, the acceleration due to gravity is a constant number regardless of the size of an size or the time, size of the object or over the time. And last section we derived this equation where we said that the velocity, final velocity is equals to initial velocity plus acceleration and times time interval. And now instead of acceleration, since it's a vertical direction where the object is moving toward Earth's surface, in surface due to the gravity, we will change these accelerations to acceleration due to gravity and modify our equation to factor the gravity acceleration due to gravity, and we can read it as final velocity is equals to initial velocity plus acceleration due to gravity times time interval. And as we said, our g value is 10 meter per second square, so we can simplify this equation and finalize our equation as b square is equals to v1 plus 10 meter per second square times time. So we will basically be using this equation in most of the cases, and we also need to remember that upward is negative, downward is positive in the case where the object is falling under gravity. And in order to work on these problems, first we need to define this term free fall. Free fall is defined as the falling under influence of gravity. So if any object is falling under influence of gravity, it's called free fall. And in these cases we will ignore the air resistance, and when and we also said before that all objects accelerates at the same rate of 10 meter per second square. And since the acceleration is same, if you drop a small ball or a big boulder at the same times and ignoring all the air resistance and this both object will fall at the same speed, and if you drop at the same point at the same time, they will hit the ground at the same time. So basically all objects fall at the same rate when only gravity acts on them. So this is a factor we need to consider, because since we are in our surface, it's not just gravity. We also have air resistance. That's why we see, for example, if we are dropping a ball and a paper, a sheet of paper, this paper will be falling slower compared to a ball because of air resistance. However, if there is no air resistance, for example, if this was done in a vacuum, then both of these objects will fall at the same rate and hit the ground at the same time. And key points we need to note is that the distance is proportional to time squared in free fall. We will look at this in some example where we are basically saying is that as you remember from previous section where we said distance is equals to v1t plus half at square, right? The distance covered was initial velocity times time plus half at square, and for an object that's falling freely, our initial velocity is 0. So we will say and g is a constant, so we can say the distance is proportional to time squared. And speed increases linearly with time, and uh, the speed will increase uh, by 10 meter per second every second. So what we are saying here is speed increases linearly. So if we go back to our previous section, we will have velocity. If we create a velocity versus time plot for a freely falling objects, then our velocity will be a linear line, and upward and downward trajectories will be symmetric, and again the same key point acceleration will be same for all the objects. Here we can go back and see here. So if you will look at this figure, we say the acceleration due to gravity g is 10 meter per second, and if you drop a ball from the top of a building, and at the beginning the ball is in your hand, that means b1 equals to 0 because it's in your hand, or meaning it's at the rest position, it's not falling yet. And if you drop it after 1 second, since the acceleration due to gravity is 10 meter per second squared, meaning the object will gain a velocity of 10 meter per second every second. So if we are saying the acceleration due to gravity is 10 meter per second square, basically what we are saying is that the free falling object will gain a velocity of 10 meter per second every second. So at the end of first second, the ball will have a velocity of 10 meter per second, and next second you will gain 10 meter per second more velocity. So at the end of the second the velocity of the ball will be 20 meter per second. At the end of third second it will increase by 10 meter per second, and will be 30, and so on. So every second your new velocity will be 10 meter per second higher than the previous velocity. Now let's look at an example here. Example problem: a ball is dropped. So here you need to be careful. It says dropped, that means it's dropping from its initial position of rest position. So b1 is equals to rest, or we can say 0. So the initially the ball was at rest. A ball is dropped from a bridge. What is the velocity 2 seconds later? So this is a case of a free fall where the ball is falling under gravity and nothing else, and we also know that the ball is dropped, meaning the initial velocity was 0, and the question is asking what is its velocity 2 seconds later. Now this question can be split into two parts, where first is what is the initial velocity. As we say, initial velocity is equals to 0 because the ball is dropped. You are not creating any extra acceleration or anything. It was, we can say it was in our hand and we just dropped it. So the initial velocity is 0, and we will look at some more example, and you need to be careful instead of just dropping, it will be a different case if the ball was thrown either downward or upward. It will be a different scenario. So the first answer is the initial velocity is 0, and let's calculate the velocity after 2 seconds. And as we said, if the initial velocity is 0 and it's under under falling under acceleration due to gravity, and there's no yield resistance, so we said every second it will gain 10 meter per second, right? So the first second it started at 0 meter per second. At the end of first second it will be 10 meter per second. That means at the end of second it will be 10 meter per second, right? The answer is 20 meter per second. So B2 is equals to 20 meter per second. We can also do this using the formula we derived previously, and let's try to solve this problem with the formula we derived before, where it was B2 is equals to B1 plus GT, right? So the final velocity we are looking at, and initial velocity we know it's G, and since it's dropping in the negative direction, in the downward direction, which we said we will consider it as a positive direction, so this is acceleration due to gravity is 10 times time is 10 meter per second square times 2 seconds. So 1 second will cancel out, so our velocity will be 20 meter per second. So you can either use your intuition and increase 10 meter per second every second, or you can simply use the final velocity formula and calculate your velocity after some interval of time. Now in the second part of the question, if the ball hits the water below the bridge 4 seconds later, how fast was it going when it hit the water? So we need to calculate the velocity after 4 seconds. So if we use the same principle, it started at 0, and 1 second it became 10, 2 seconds it became 20, 3 seconds it became 30, 4 seconds it will be 40. So 40 meter per second, and again if we use the formula, then velocity is B1 plus GT, and B1 is 0 plus 10 meter per second square times, now time is 4 second, which is 40 meter per second. So the velocity at the end of 4 seconds is 40 meter per second. So we can either use this method or use a formula to solve this problem. And now we have another question here. A ball is dropped. Again, ball is only dropped, that means we don't have any initial velocity. Initial velocity is still 0. From a building, it falls for 4 seconds, and it falls for 4 seconds. How tall is the bridge? So basically what it's asking us is, for example, if this is the bridge and the ball dropped from here, and it took 4 seconds for this ball to reach the surface, that and it's asking what is the how tall is the bridge. Basically it's asking the distance covered by the object. So if we simplify this question, it's basically asking us distance covered by the ball in 4 seconds. Note again, we can so in order to calculate distance, what we can do is, what do we know? Velocity is equals to distance over time, and if we need to calculate distance, then we can say velocity is times, and this formula we have been using it since the starting of the chapter. And in order to use this formula, what we know is this velocity is the average velocity, and in this case if you look at here, it started at 0, and after the 4 second, the velocity we just calculated in the previous equation is velocity at 4 second equals to final velocity is it was 40 meter per second, and we know that b average velocity is b1 plus b2 over 2. Our initial velocity is 0 because it was only dropped, there's no initial velocity, plus b2 is the velocity at the end of 4th second, which is 40 meter per second, and divided by 2 is 20 meter per second. So this gives us velocity, and if we need to calculate the distance, covered is delta x equals to velocity times time it traveled. So 20 meter per second times it traveled for 4 seconds, so total 80 meter. So the bridge is the building is there's a building here, there's a bridge here, so this will be building is 80 meter tall. Now for this problem, what we could do is use this formula as well. If we use this formula, what will be our solution? Distance traveled is initial velocity is 0 plus half into g is 10 meter per second square, and time is 4 seconds, so 4 second squared is equals to this is 16, this is second square cancels out, then our answer will be 5 times 16, which is 80 meters. So we can either use this average velocity, or we can also average velocity, we can either use the average velocity formula, or we can use our formula we derived previously and calculate the distance covered. And now comes an interesting part where instead of free fall, the ball is thrown down at 10 meter per second, which means the initial velocity is now 10 meter per second instead of 0. So if it was dropped, then our initial velocity would be 0, but instead of just dropping it, the ball is thrown downward at 10 meter per second, and we need to calculate what will be the velocity after 2 seconds. So time is 2 seconds, and we are asked to find the final velocity. Final velocity is equals to v1 plus at, and v2 is equals to v1 plus at is equals to 0 plus acceleration is, sorry, I will just use gt instead of at since this problem is under gravity. So 10 times 2 is equals to 10 plus 20 equals to 30 meter per second. So we can use this formula to calculate the velocity. We could also use the same principle that the object falling under gravity will gain a velocity of 10 meter per second every second. So 10 meter per second every second. So it started with 10 meter per second. At the end of 1 second it will be 20 meter per second, and at the end of 2 seconds it will gain 10 more meter per second, so the velocity will be 30 meter per second. So you could either use this formula or simply add 10 meter per second every second, even for the case where the object is thrown instead of just dropped. However, you have to factor that the initial velocity is some value instead of 0. Again, for 6 seconds it will be the same formula. v2 is equals to v1 plus gt 10 meter per second plus 10 meter per second square times 6 is equals to 10 meter per second plus 60 meter per second, which is 70 meter per second. So the velocity after 6 seconds is 70 meter per second. Again, if we keep continue this the other method, we will have for after 3 seconds it will be 40, 4 seconds, 50, 5 seconds it will be 60 meter per second, and at the end of 6 seconds it will be 7 meter per second. Now all the examples we did so far is for the object that is moving downward. Now let's look at an example where the ball is thrown upward. Now if we remember, downward is our positive in this case and upward is negative, and it says the ball is thrown upward at 10 meter per second. That means our initial velocity is equals to minus 40 meter per second, minus because it is going upward. What is its velocity after 1 and 2 seconds? Now again we can use the same formula. I will show you in the both method. So after 1 second, so when time is equals to 1 second, final velocity is equals to initial velocity plus gt is equals to, initial velocity is now 40 meter per second plus g is 10, because gravity is still downward, so it's not changing. It will still be 10 meter per second squared, and time is 1 second. This is minus 40 meter per second, and this is plus 10 meter per second square. So the answer is minus 30 meter per second. After 1 second, the velocity will be minus 30 meter per second. Similarly, if we redo the formula again for time 2 seconds, velocity is equals to v1 plus gt is equals to minus 40 meter per second plus gravity is 10 meter per second square. Now time is 2 seconds. So if we calculate this, minus 40 meter per second plus 10 into 2 is 20 meter per second, and still this will be 20 meter per second. And for 6 seconds it's the same. b2 equals to t equals to 6 seconds. b2 is equals to b1 plus gt is equals to minus 40 meter per second plus 10 meter per second square times 6 seconds, right? And if we calculate this is minus 40 meter per second plus 10 into 6 is 60 meter per second. Now this is, now 60 is positive, 40 is negative, so 20 meter per second. So remember, these first two cases are still in negative value, and third case is that after 6 seconds the velocity is positive. So what this means is the ball was thrown up with 40 meter per second, and it reached some point here and then it starts dropping, right? So at t equals to 1 second, t equals to 2 seconds, because it was still going up, it was negative, and then after some times the ball start falling down, and at t equals to 6 seconds the velocity is 20 meter per second. And one thing we need to analyze here is that at the peak, when the ball, you throw something and we know that the object would ultimately fall down, at some point it has to change the direction from upward to downward. That means at that point it has to have a velocity of 0, right? So that's the highest point where the ball will change the direction, the velocity will be 0. And this second section is asking us how long does it take to reach its highest point. So this is what it's asking. So it's asking how long, what's the time taken for the ball to reach this point where velocity will be 0. So basically we know that at highest point final velocity will be 0, right? So we can use the formula again. v2 is equals to b1 plus at, and b1 is minus 40 meter per second plus v2 is 0. Sorry. So b2 is 0 because we are looking at the point where is changing its direction. So the velocity it's 0. Initial velocity is given here, minus 40 meter per second, and acceleration is 10 meter per second, and we're calculating time. So if we simplify this equation, it will be 0 equals to minus 40 meter per second plus 10 meter per second into time. Now if we isolate time, 10 meter per second t is equals to, we take this 40 meter per second on the other side, so it will be positive 10 meter per second, and if we isolate t, it will be 40 over 10, which is 4. This will be squared 4 seconds. So it will take 4 seconds to reach the object to its highest point. And one thing we can also do is use the same principle. We can solve this problem using the same method as we did before, where we said that every 1 second the object will gain a velocity of 10 meter per second. For example, let's see 1 second. So the initial velocity, okay, let's see 1 second initial velocity was minus 40. Okay, let's start with 0, because it started at 0 second, right? So at 0 second, or we can say at the initial position, it was minus 40 meter per second. After 1 second, it will be minus 40, and we say it will gain 10 meter per second every time. So plus 10 equals to minus 30 meter per second, and at the end of 2 seconds, it will gain 10 meter per second more. So it will be minus 30 plus 10 equals to 20 meter per second, which is negative as well. At the end of 3 seconds, it will be minus 20 plus 10 equals to minus 10, and so on. So you can repeat the same and you will get the same answer. So you can either use the formula, or use this logical method, where you will add 10 meter per second of velocity on the object every second it travels.